Good afternoon. So, we have a robot system. We have to deploy that in a greenhouse or a cropping system. So that is what I will talk about today. So this is my outline. So, okay. So if we go inside the greenhouse, we can see very many things. Plants. So like a greenhouse here, you can see plants, and it's quite a big greenhouse. In this greenhouse, it's quite a small greenhouse. You can see racks, you can see small plants, but this is a very inhomogeneous system. The greenhouse is a very inhomogeneous system. It can be different. It can have different things. So there's a dog also. So greenhouses. So this is very inhomogeneous. So we have to compensate with this greenhouse system. So normally in today's researchers, they have different kind of robots. So mainly they use a camera. As you can see here, there's a camera. There's a camera. So camera is used, and the information is gained from the camera and sent into the to the processing. And this system works. And there's another system which uses a guide rail system, the rail system here, and use an indicator-based system where we place different indicators in the path so the robot can know where it is. So this is our system. So I think you have seen this. This is from Vidosana's presentation. So this is the speaker. We have 4 nodes where these are the microphones. This is the microphone, and this is the speaker, and this is the microphone. So the sound is emitted from the speaker, and the microphone captures it. So this GIF will show you how does that work. So this robot emits the sound, and the microphones catch it, and then the calibration station emits the sound, and the microphone decide, okay, this robot is this far from me. So it can't decide where it is, but it can say, okay, this robot is that much far from me. And the second microphone also does the same. The second microphone also does the same and decide, okay, this robot is this much far from here. And the third with the third microphone, you can locate the robot inside the greenhouse or the system. And if you use a fourth microphone, we can also decide the height of the robot from the ground. So this is what happens when we put the robot inside the greenhouse, maybe what may happen. So these are the crop rows. Robot has to go through them, but because of these crop rows, the robot, the sound may the sound may change the direction. I didn't put the calibration is also there. So this is what may happen if we put a robot inside the greenhouse. So this is the problem with the greenhouses. You have very many things. You have plants and high humidity, temperature gradient, wind, and obstacles. There are many things. So if we consider about the temperature gradient does pose a problem, because the cool air, in the cool air, sound travels slowly than the warm air. The temperature will change the sound direction. That's a problem. In the greenhouses, actually the temperature changes with the time, and we normally have a temperature control system. And this the warm air. So the plants poses a different problem. Reflection. where the sound emitted, as you saw in the robot emits the sound, and when the sound is emitted, it can be reflected from the plants, or it can be scattered. Scattered means the sound hit the plant and it's scattered to different directions. And the sound can be diffracted. Diffracted means when you have an obstacle, sound tend to bend in the near the obstacle. That's the diffraction. So because of these things, the sound will cause multipath effect. This is the multipath effect. You can see the sound can take different paths. So as you can remember the first year, the GIF I saw you, if the sound takes these different paths, this has to draw its circle around here, but the robot is there. Because the sound takes a curved path, this is not going direct. This is a problem. So this is the multipath effect. So the Vidya has done some work on this. And what I will try to do is, I'll do a preliminary investigation and then redesign the system. Means first I'll try to change the frequency, because the frequency has a big effect on the sound behavior. And then the change in the arrangement of the components means you just don't arrange them like that. Some different arrangement I'll try. And this multi-sensor approach. This means if you can't get the signal somewhere, we can use these other sensors, that like dead reckoning sensors or gyro sensors, to locate the robot. And the frequency change is the most desirable candidate, but there's a problem with the frequency. Increase the detection time, and it will increase the detection time, and frequency is lowered, it will be subjected to high amount of background noise. I'll show you okay. So this is what will happen. So you can't hear it, no? So these are more familiar noises. That means this adding background noise. Okay. Okay. So that's a problem. And if we reduce the frequency, there's another problem: the detection time. Can you see these two peaks? The time to come to the ear is increasing. So that means it increases our detection time. That's another problem. So okay. So ultimately, I'll try to navigate the robot inside a crop field or a greenhouse. And thank you very much.
Very quick summary. Yeah, any question? Yeah, would you tell us a summary?
Okay. So the greenhouse environment is highly variable. The variable is adversely affecting the operation of our system. So different approaches can be taken into this problem. So that's what I talked about last.
Any question?
When you first started out trying to point out high variability,
Yeah.
you used slides of a greenhouse, but of mostly with one commercial greenhouse, but then there was two very small hobby greenhouses.
Right.
and very cluttered, and so there's no room for robot to move.
This one. Oh. Where is it? This one.
No, next one.
This thing.
This.
Yeah.
And then your next slide is our system. No, next one. Where is yours? Yes. No greenhouse.
That is the problem we have. So we have to put it in this.
In terms of consistency, are you going to do commercial greenhouses, or are you going to do hobby houses also? Are you going to do outside? You are confusing the person viewing it if you do not have a consistent message.
Actually, I'm trying to first some homogeneity, and then next only we will go for a this system. If we use it in a commercial greenhouse, that's the first priority. Then we will go for the other inhomogeneous systems. And that's it. So this is actually outside. So we have to put it in.
It would help if with a consistent message. So
okay. Yes.
We don't need to know those details.
Anyone else? Yeah. Would you give us your future project if you already decided? What kind of project? I understand this kind of some positioning systems, but maybe you showed us some obstacle, some plants would be obstacles if we use this system in greenhouse.
This thing? This thing? This thing?
Yeah, this, plants and humidity, also temperature. Wind also
it's like if you use a fan or something inside the greenhouse. They use some fans to reduce the temperature or something. The wind can become obstacle.
Yeah.
But it's
many problems we have. So which targets are you most interested?
Firstly, I'll try because the plants are the biggest problem. Then plants, then only temperature and the
Plants absorb the this sound waves.
Yeah, the absorption is a little problem, but yeah, absorption is a problem, and this multipath is the biggest problem.
But if you put your speakers very high place, higher than plant's height,
yeah, maybe
no problem.
Actually, that's what I told the change in the system configuration. So I'll try that first. If that solves the problem, yeah.
So, what's the condition when you are preparing this your project, and what's the target? Also, what's the actually objectives? We should be clear. Next time. Anyone? I have to introduce Professor Chen. Yeah, he came from China Kyoto University, Beijing, and he temporarily staying here 3 nights, 4 days, 4 days. And yeah, he joined this laboratory seminar. Do you have any just message to us? No. Of course, you can. Yeah, Hansan may translate into if necessary. Give us English message if possible.
我来自那个中国农业大学，来这个参加咱们这个真理，来体会一下咱们真理的方式。I'm from Taiwan University. This seminar to learn from you. 我是原来在日本留学，学日语，没有学英语，所以呢。这个读写看的还差不多，说的话听不清。
I got my PhD degree in Japan, and my Japanese is okay, but English I can read and listen, but I cannot speak. Sorry.
来这里访问了以后，我觉得咱们京都大学，咱们这个研究室呀，非常国际化，许多国家人都有，是吧？我觉得，如果能在这样的环境学习吧，应该是觉得非常幸运的。
After visiting our laboratory, I feel our lab is very globalized, and I think you have experience in our lab. You are very lucky.
Thank you.
The reason why I remembered about him is he is the expert about machine vision and automation in young culture. So if you have any question or any suggestion to him,
okay. 我看了他这个用声音来进行这个控制这个车的。这个思路是很好的。
I know you try to control the robot by using sound. It's a very good idea.
这个和图像比啊，所以我认为应该像人一样，人的视觉，这个视觉听觉，就是这个把两个全都用上的，可能比这个光听觉或者光视觉会好一些。
I think if you can combine machine vision and also with sound, like our human when we work, so it would be better.
如果有兴趣呢，也考虑一下，就是用视觉来弥补这个声音的不足吧。
If you have interest, you can try to apply machine vision on your system.
应该是视觉有视觉的优势，听觉有这个声音有声音的优势，应该把两个优势结合起来。视觉就是信息面广，就是他能看你的信息面广。那是太看了。这个听觉的优势，那个声音的优势能测距，因为这个测距方便。视觉检查测距，但是声音方便。
The method of sound is that you can measure the distance accurately, and the merit of machine vision is that you can get much more information.
Thank you.
If you have any feedback or some comments, it's okay.
If we use a machine vision, the problem is the speed of the system and the processing time. So that's what normally we went for sound system. So if the processing time is okay, we can use the machines. If now the computers are more faster, so maybe the processing time will be okay. We can use the machines. And the cost.
Okay, any other questions or comments to him? I wish you more earlier start your own project. Thank you very much for your contribution.